Look at a few more examples of difference of squares, and I'm going to take 1 over 81 minus x squared, or let's make it minus y squared, and this here is equal to, really, as long as I've got two terms and I've got a minus between them, they can factorize according to the difference of squares. That means I just take the square root of this entire fraction, which is just square root of 1 is 1, square root of 81 is 9, and I say minus the square root of y squared is just y, multiplied by 1 over 9 plus y, and that's it. As simple as that. When I multiply these two, I get 1 over 81. When I multiply those two, I get y squared, and because that's plus and this is minus, I get the minus over there. Remember, this must conform to the way a difference of squares looks. Okay. Let's take another example. Now this example, I'm going to call it example number 7. Now example number 7 is a bit of a tricky one because it's 2x squared minus 32. Now the golden rule of factorization, rule number 1, is always seek the common factor first. Always seek the common factor first. So let's see, do we see a common factor present over here? Well, there is a common factor. The common factor over here is 2. So let's take out that 2. Right. Now 2 times what? That's x squared minus 16. Because 2 times x squared gives me 2x squared, and 2 times 16 gives me 32, and a positive times a negative gives me that negative. Now once you get here, you can see that clearly this thing isn't completely factorized because I still have a minus between two terms, and these two terms, they are essentially perfect squares. So I'm going to say that's x minus 4, because I just take the square root of x squared and I place it there, and the square root of 16 and I place it there. I do exactly the same thing in the next bracket, and I separate it with a plus sign. Okay, so you always seek the common factor first. Right, example number 8. Let's make it a b to the power of 6 minus a. Well, always seek the common factor first. And what's common over here is a. A times b to the 6 gives me ab to the 6. And a times negative 1 will give me negative a. And so that first part is factorized. Now the moment I have two terms separated by a minus, remember they can always be factorized, and that's according to the difference of squares. And so this is going to stay a, this is going to be b to the power of 3 minus 1, and that's going to be b to the power of 3 plus 1. When you multiply these two out, you get b to the power of 3 plus 3, which is b to the power of 6. And when you multiply these two over here, you get 1, and negative times a positive is negative. Remember, you can also do this the long way. Be sure that you've actually worked through all the previous videos as well. Okay, so that's example number 8. Let's look at example number 9. Okay, so what we're going to do is we'll stop at this example, but let us just quickly, we'll stop at 10 examples. So let's make it 49 minus a squared b squared. And this two terms separated by a minus, immediately you know you can factorize that into a difference of squares. So that's 7 minus ab multiplied by 7 plus ab. Okay, because a times a gives me a squared, b times b gives me b squared, negative times positive gives me the negative, and 7 times 7 gives me the 49. Very easy. One more example, and then in a separate video I'm going to do a little bit more advanced example. Okay, so let's take 81 x to the power of 4 minus 121 y to the power of 6. This is equal to 9x squared, because the square root of 81 is 9. Square root of x to the 4 is x to the 2. And this is very important. I'm talking about the square root of x to the power of 4. and that's equal to x to the power of 2 times x to the power of 2. And because of this, it means that the square root of x to the power of 4 is really x to the power of 2. Right? Similarly, y to the power of 6 is equal to y to the power of 3 multiplied by y to the power of 3. And when we take the square root, we ask ourselves, what can we multiply by itself to get that result? And so this over here is really the result for that. So this is going to be the square root of y to the power of 6. So it's 9x squared minus 11y to the power of 3 multiplied by 9x squared plus 11y to the power of 3. Okay, so that gives us the next 5 examples. And then there's one more that's going to be a more advanced, more grade 11 and grade 12 learners should take note of in the next example.